Uh, Good day, everyone. Okay, so today we will discuss several examples for our topic torsion. Okay, so to those who have so these following problems in our video came from the book of Pytel and Qsalaas in Mechanics of Materials, 3rd edition. I know, 2nd edition. Okay, so first, we will try discussing the solution of our first three problems from 3.1 up to 3.3. Okay, so here we are. Okay, so we start with 3.1. The steel shaft, 3 feet long and 4 inch in diameter, carries the end torque of 15 kip-foot. Determine the maximum shear stress in the shaft, and B, the angle of twist of the shaft. Use G, or the angle of rigidity, 12 times 10 to the power of 6 psi for steel. Okay, so without further ado, we'll try we'll try this problem. Okay, so I have there here in my hand is a solution to that problem. Okay, so maybe so this is okay, so I rewrite actually the problem here. Okay, so first we identify we solve the maximum shear in the shaft, and then B, the angle of twist of the shaft. Okay, so we have this following solution. Okay, so from this is actually our copied figure. Okay, from this, so I just copied it, and then we'll have a solution. Okay, so we have a 15 kip-foot torque. It is 3 feet in length and 4 inch in diameter. Okay, so we have this formula. Okay, so take note that this formula for maximum shear, this is applicable for circular shafts only. Okay, specifically solid circular shaft. Okay, so first we're gonna discuss how it is done. Okay, so since we have given 15 kip-foot, okay, first thing we do is we convert it into kip-inch. Okay, so 15 kip-foot we multiply by 12 inch over 1 feet, so we get 180 kip-inch. Okay, and then we have the D 4 inch. Okay, so we substitute the value of T and D respectively to this formula. Okay, so we get the maximum shear stress 14.324 KSI. Okay, so you might ask class, why did I convert the kip-foot into kip-inch? Okay, so one thing we should be careful while solving problems is we need to have a uniform unit. Okay, so for the unit of length, we have inch. Okay, so basically we cannot cancel out if the top will be kip-foot, and then the diameter is in inch. Also, we cannot cancel out a foot with inch. Okay, so it needs to be uniform in a single unit, and I choose to convert every unit of length into inches. Okay, so that it will cancel out from here inch to the power of 1, and at the bottom inch to the power of 3. So we got kip per square inch, or KSI, or 14.324 KSI. Okay, so always remember that the length and the weight should have uniform units, or else you will get an erroneous answer. Okay, so letter B, we compute the angle of twist of the shaft. So here we go. So this is the solution. Okay, so we have this formula. Theta, or the angle of twist, is equivalent to T times L over G times J. Okay, so where T is the torque, L is the length of the shaft, G is the modulus of rigidity, and J is the polar moment of inertia. Okay, so just like what we have done, okay, so we have already converted the 15 kip foot into 180 kip inch. So here I reconvert it into libra inch. Okay, so in order that we can use the unit libra, okay, or pounds. Okay, so this is the formula for polar moment of inertia for circle. Pi times d to the power of 4 over 32. Okay, so we just substitute the value of your diameter to this formula, so we get pi to the power okay, pi, so we get pi to the power pi times 4 to the power of 4 over 32. Okay, so in order that we will not have uh, a round of errors, I take it as it is. Okay, so L, okay, the length of your shaft is 3 feet. I convert it into inch so that we will have a uniform units. Okay, so the units of this J is actually inch. Okay, this is actually inch to the power of 4. Okay, so we have a single unit for pounds, which for weight, which is libra, and we have a uniform unit for length, which is inches. Okay, because we will use 12 times 10 to the 6 psi. Okay, psi is libra per square inch. Okay, so that it will cancel out the libra and we will get the inch. Okay, so from this we computed our theta as 0.0214859, and then please do remember that this formula, class, will result in a value in radian. Okay, you will not get directly the degrees, radian. Okay, so in order to convert your radius into degrees, okay, so in order to convert your radian into degree, you multiply radian by 180 divided by pi. Okay, so if we do that, we get 1.231 degrees. So this is our answer. Okay, so please take note that this is your okay, so this is your uh, problem, and these are your solutions. Okay, so maybe, okay, we'll proceed to our next example. Okay. So where is it? Okay, so I'm lost. So next is 3.2. Okay, so we'll try solve our example will be 3.2. Oh, this is its figure. It has a length of 6 meter and applied torque of 12 kilonewton meter, and the D is not given. Okay, so let's read the problem. Okay, so the 12 kilonewton meter torque is applied to the free end of the 6 meter steel shaft. The angle of rotation of the shaft is to be limited to 3 degrees. Okay, so we find the diameter D of the smallest shaft that can be used, and B, find the what will be the maximum shear stress in the shaft. Okay, use G, or the angle of rigidity, is equal to 83 gigapascal for steel. Okay, so without so much ado, we will have, okay, example. Okay, so I have, just like before, I have pre-solved this example. Okay, so 3.2. Okay, so this is your I just copied the problem. Okay, so first, find the diameter D of the smallest shaft that can be used, and B, what will be the maximum shear stress. Okay, so given that the limit of your angle of rotation should be less at 3 degrees. So therefore, we got this inequality. Theta should be less than or equal to 3 degrees. Okay, or theta max is equal to 3 degrees. Okay, so just, okay. In order to convert these degrees into radian, you just multiply it by pi over 180. So this is your multiplier. So multiply 3 degrees by pi over 180, it will result to 3 pi over 180 radian. Okay. You cannot equate directly the degrees. You should convert it into radian so that you will not get the erroneous answer. Okay. So just like, okay, so this is the formula for your angle of torque, TL over GJ. Okay, so we have given the value of torque, which is 12 kilonewton, applied torque, which is 12 kilonewton meter torque. Okay, so I can, okay, so I multiplied it by 1000 newton, okay, 12 kilonewton, okay, times 1000 newton per 1 kilonewton. Why? So I convert it into newton meter so that it will, okay, so that G here is 83 gigapascal. So 1 gigapascal is equal to 10 to the power of 9 pascal. And then pascal is equivalent to newton per meter squared. Okay, so I tried it to be uniform value of force, which is newton. Okay, and then we have meter. So since we use meter length, so this D, the resulting value of D will be in meter also. Okay, so please beware in converting your units. Okay, you might not get the exact answer. Okay, so therefore, okay, so we get this one is equal to 3 pi 180 over multiplied by pi over 32D over 4, okay, by algebraic manipulation. So from this one, we can solve the value of your diameter as equivalent to this following, 0.013976147. And since the unit that we use in this is uniform in meter, so what we get initially is in meter. Okay, and then since it is in meter, I multiplied it by 1000, so I get 113.976 mm. So this is the answer. D is equal to 113.976 millimeter. Okay, so we have the maximum shear stress. Okay, so we get that D, so we can already compute the maximum shear stress. Okay, so remember this formula again, 16T over pi D cube. Okay, this is good for solid shaft. And then we still convert your kilonewton meter. Okay, this time I converted into newton millimeter. Okay, so I multiplied it by 1000 newton over 1 kilonewton to convert it into newton. This kilonewton will be newton, and then I multiplied it again by 1000 mm over 1 meter in order to convert this meter into millimeter. Okay, divided by pi over 113.976 millimeter cube. Okay, because I use mm for D. So what I get is newton per mm squared. And please take note that 1 newton per mm squared is equivalent to 1 megapascal. So our computed maximum shear stress is 41.277 megapascal. Okay, so let's review. So this is your problem, and these are your solutions. Okay, so we'll try another example. Okay, so we turn it out to 3.3. Okay, so we go to 3.3. Okay, so the torque, okay, so the torque of 100 kip-foot produces a maximum shear stress of 8,000 psi in 16 feet long hollow steel shaft. Okay, note that the inner diameter of shaft is 2/3 of its outside diameter D. So these are the question. Determine the outer diameter D and find the angle of twist of the shaft. Use G, or the angle of rigidity, is equivalent to 12 times 10 to the 6 psi for steel. Okay, so this time we use imperial units. So this is actually our solutions. Okay, so this will be our solution. Okay, so determine the outside diameter. Okay, so since there is no figure available, so I draw the figure. Okay, so this is now the figure. Okay, based on the problem. Okay, so we have 100 foot torque. It has a 16 feet length, and it has an outside diameter and d, and it has an inner diameter small d. And according to the problem, the inner diameter of the shaft is 2/3 of its outside diameter. So therefore, the small d is equivalent to 2/3 of big D. Okay? So in this picture out, okay? So since it is given that the maximum shear stress is 8,000 psi, we can use it in order to compute your outside diameter. Okay? So please remember that the formula for your hollow steel shaft is different from solid shaft. Here, the maximum shear stress is equivalent to 16T multiplied by big D divided by pi over big D to the power of 4 minus small d to the power of 4. Where your big D is the outside diameter, and your small d is the inner diameter. Okay? And we equate it into 8,000 pounds per square inch because the maximum shear is given 8,000 psi, or 8,000 pounds per square inch, or 8,000 libra, okay, per square inch. So here again, we need to convert each unit into one uniform unit. Okay, so we have kip, okay, unit for weight or force, and we have foot, the unit for length. Okay, so I convert this foot into inch. So I multiplied it by 12 inch over 1 foot. And then in order to convert your kips into libra or pounds, I multiply it by 1,000 pounds or libra over 1 kip. And then multiplied by D. So since we don't know the value of D. And then again, we know that your small d is equivalent to 2/3 of D. So I also put it in this one. So we have one unknown, which is the big D, and equate it to 8,000 libra per square inch. Okay, so by this we have a uniform unit, one keep libra inch at the top. So okay, so here I cross multiply. Okay, so I multiply this one to the right side. Okay, so we have 19,200,000 D is equal to 8,000 pi multiplied by big D to the power of 4 minus 2/3 of big D to the power of 4. Okay, quantity. So what we get is the value of your outside diameter, which is equivalent to 6.919 inch. So this is our answer. And then for letter B, okay, we tried to solve the value of your angle of twist. Okay, so so since all are given now, 100 keep, this is keep, I'm sorry, keep foot, I multiplied it by 12 inch over 1 foot in order it will become keep inch. And then I convert the foot, the length L, into inches by multiplying 12 inch per 1 foot. Then divided by 12 times 10 to the 6 psi or libra per square inch. Then multiplied by pi over 32. We use the values of D, and then the value of small d, which is equivalent to 2/3 of the outside diameter. Okay, so we substitute everything. So we get 1.0634073 times 10 to the negative 4 radian, or 0.00609 degrees. So this is your angle of twist. Okay, so I repeat, in order to get the value in terms of degrees, you multiply the value in radian by 180 divided by pi. And then when computing you need to consider converting all your units uniformly, whether it is in length, like foot, you need to convert it to inch. So if you use, and you need to your unit should have inch overall. And then if you use libra, you convert everything into libra in order that you will not get the erroneous answer. Okay, so let us review. So this is your problem, and this is your solutions. Okay, so thank you. So we will have another solution on the next video.